Okay, today we're going to talk about nuclear magnetic resonance spectroscopy, or NMR, and more particularly 1H nuclear magnetic resonance spectroscopy. Okay, this is a very powerful technique which enables you to work out the structure of an unknown substance. Very briefly, you get a sample. Your sample is placed in a very strong magnetic field, and then radio waves are shone through the sample, and there's a detector there, and hydrogen nuclei in the sample will absorb the radio waves. Okay, so what does a spectrum look like? A very basic spectrum. Well, you'll have something like this. This scale is usually marked as ppm. We'll talk about what that means later. And you'll see something like this. Okay. What's on the x-axis, or on the y-axis, sorry, we have that is your absorbance of the radio waves. And what are we increasing on this scale? In actual fact, the strength, usually it's the strength of the magnetic field is increased. Okay, so as you go along there, the magnetic field strength is increased. Okay, so if you just have a look here, there, low magnetic field strength, there's no absorbance of radio waves, and then as you increase it, there's no absorbance, then all of a sudden some of the hydrogen nuclei start absorbing here. Okay, and you get one peak, no more absorbance, and as you increase the field strength, and then another set of hydrogen nuclei will absorbing here, and then you get zero absorbance of radio waves, and then finally you get some more hydrogen nuclei absorbing there. Right, each of those peaks, each peak represents a particular environment of hydrogen nuclei. Okay, well, what do I mean by that? Well, let's have a look at propane down here. Okay, so there's propane. You can probably see there that all of those hydrogens, so there's 8 hydrogens, but they're not all the same. Now it's fairly obvious that all of these 3, they're all attached to the same carbon, so they're identical environment to each other. And because there's a symmetry in this molecule here also, that these 3 are also identical to them. And then if you looked at these 2 hydrogens, well, these are the same as each other. They're both attached to the same carbon. So propane will actually give you an NMR spectra of, it will give you 2 peaks. And the area under the peaks, which is called the integrated value sometimes. So you can see the blue ones, there's 6 of them. So the blue you would give, that would be those hydrogens with area under the peak would be equal to 6. And the green, there's less of those. There's only 2 of those. So the area under that peak would be 2. Okay. Right. Come back to that later, but let's just have a look at a few more molecules, simple organic molecules, and you can pause the video and work out how many different hydrogen environments they have. Okay, so here we go. So methane, ethane, let's have ethanol, let's do, let's have like pentanone. Okay, so there's a ketone functional group, and because it's on carbon atom number 2, you'd call that pentan-2-one. And if you put it on carbon atom number 3, it's different. That's pentan-3-one. So let's have a look at how many environments there. Excuse me for not putting all the hydrogens on there. Well, methane is fairly obvious. They're all the same, aren't they? That will just give you 1 peak. 1 peak, 1 environment. Ethane, that's 1 peak as well, isn't it? 'Cause yeah, you've got these 3, but they're absolutely identical to those 3 as well. So that will give you 1 peak. Ethanol. All right, so you'd have those 3 are all the same. These 2 are the same as each other. And finally, the hydroxide hydrogen, that's going to be different. So that's going to give you 3 peaks. Do this one slightly differently, as I'm going to run out of colours. Right, so let's have a look. You've got those 3 hydrogens, they're all the same, aren't they? But they're not the same as these 3 here. Okay, these are different because, well, yeah, it's a CH3 group, but this CH3 is next door but 1, 2, 3 to the carbonyl, whereas this CH3 is right next door to the carbonyl, so they're not the same as each other. These 2 hydrogens, they'd be the same as each other, but they're not the same as these 2. They're different because they're next door to the carbonyl. So pentan-2-one will give you, that's going to give you 4 peaks. Let's have a look at pentan-3-one. So now there is symmetry here. So you've got those 3 are the same as those 3 there. And those 2 are the same as those 2 there. So that would only give you 2 peaks. So if you just think about these 2 compounds here, pentan-2-one and pentan-3-one, it'd be very easy to distinguish those 2 using NMR, because this one will give you 4 peaks and that would only give you 2. Now, if you think about the infrared spectra of these 2 compounds, well, they're going to be very, very similar and you wouldn't be able to distinguish them at all from each other. So it gives you a little bit of an inkling, first of all, of just how powerful 1H NMR is to enable you to work out the structure of molecules. Okay, we'll leave that there and on with the next video.